Welcome to Teolumen Insights, where we reveal the hidden forces that shape the way you live and show you how to use them to create real transformation and supercharge your health, mindset, and daily life. Here are your hosts, Emma Greenwood and Nathan Sinclaire.
Welcome to Teolumen Insights, where we take your curiosity and really dive deep into some fascinating topics.
That's right. We love to explore the most intriguing corners of knowledge, you know?
And today we're tackling one that's been generating a lot of buzz lately. It's Andrea Rossi and his invention, the ECAT.
Oh, the ECAT. Yeah, this is a story filled with claims of revolutionary energy production. You know, whispers of a secret catalyst.
A lot of head-scratching going on in the scientific community, for sure.
Oh, yeah. A bit of a scientific detective story, wouldn't you say?
Absolutely. And you know what? We have a whole stack of sources here. Articles, research papers, even snippets from a book called Secrets of the ECAT.
Ooh, Secrets of the ECAT. Sounds intriguing.
It does. So let's dive in. Where do we even begin with this whole ECAT mystery? What is this thing supposed to do?
Okay, so at its core, the energy catalyzer, or ECAT, is a device that Rossi claims can generate heat through low-energy nuclear reactions, or LENR for short.
LENR.
Okay.
I've heard that term thrown around, but I'll admit I'm a bit fuzzy on the details.
Sure, so imagine a metal tube filled with nickel powder and hydrogen gas. Rossi says that with the addition of a secret catalyst, these elements undergo a reaction that produces a significant amount of heat.
Okay, so we're talking nuclear reactions, but not like the kind we see in power plants.
Right, exactly. Traditional nuclear power relies on fission, which is splitting heavy atoms like uranium. This requires incredibly high temperatures and pressures. What Rossi is proposing with the ECAT is something quite different: low-energy nuclear reactions. He claims these reactions can occur at much lower energies, even near room temperature.
So instead of needing a miniature sun, he's saying he can trigger these nuclear reactions with something as simple as a catalyst.
That's the core of his claim, and it's a bold one, which is why the ECAT has been met with so much skepticism from the scientific community.
Right. There's no real consensus on whether these LNRs are even possible, let alone achievable with a device like this.
Exactly. It's a big question mark. And then, of course, there's the whole mystery surrounding the secret catalyst.
Ah, yes. The secret sauce. The key to unlocking this whole puzzle.
It really is. And Rossi has been notoriously tight-lipped about its composition.
Which just fuels the skepticism even more, I imagine.
Oh, absolutely. But our sources do offer some tantalizing clues.
Okay, let's hear them. What are we working with here?
Well, one possibility is that the catalyst isn't a separate ingredient, but rather a specific structure or treatment applied to the nickel itself.
Interesting. So it's not what he's adding, but how he's preparing the nickel.
That's one theory. Rossi's patent mentions a process that changes the nickel powder's isotopic composition.
Isotopic composition. Now, I remember that term from chemistry class, but a little refresher would be helpful.
Sure. Think of it like this. Each element exists in different forms called isotopes. They have the same number of protons, but a varying number of neutrons. Rossi might be using a specific mix of nickel isotopes that are more likely to undergo these low-energy reactions.
So it's like he's found a particular flavor of nickel that's more reactive.
Precisely. He could be tailoring the nickel to make it more receptive to interacting with the hydrogen. But there are other theories, too. Some researchers speculate that the catalyst might involve additional elements like copper or zirconium.
So it might not be just about the nickel itself, but a specific cocktail of elements that make the reaction possible.
That's another possibility. And then there's the idea that the catalyst might play a role in breaking down the hydrogen gas into individual hydrogen atoms, which would mean a higher concentration of protons ready to interact with the nickel.
Ah, so it's all about setting the stage for those protons and nickel nuclei to get up close and personal.
Exactly. But there's another fascinating layer to this. One source mentioned a Rossi-like experiment where tritium was detected.
Tritium. Now that's a radioactive isotope of hydrogen. If that's present, it raises some serious questions about the safety of this whole thing.
Absolutely. It suggests there might be processes happening within the ECAT that are more complex and potentially more risky than Rossi has let on.
So at this point, we've got a whole range of possibilities. A special nickel structure, a specific mix of isotopes, additional elements, maybe even something involving radioactive materials. It's a genuine scientific mystery.
It really is. And this secrecy surrounding the catalyst is one of the biggest hurdles to understanding how the ECAT is supposed to work, let alone verifying its effectiveness.
Okay, so let's say for a moment that Rossi is on something.
Well,
How could a device like this actually produce energy? This is where those scientific concepts you mentioned come in, right?
yes, and it's where we enter the realm of theoretical physics.
Mm-hmm.
Remember, this is all speculative, but Rossi and some of his supporters have linked the ECAT's supposed mechanism to some pretty mind-bending concepts. You mentioned the Casimir force, for example.
Yes. The Casimir force, it has something to do with the energy of empty space, right?
That's the gist of it. The Casimir force arises from quantum fluctuations in a vacuum. Even in seemingly empty space, there are tiny particles popping in and out of existence. These virtual particles can exert pressure, and under specific circumstances, this pressure can be significant.
Wait, so empty space isn't actually empty. There's a whole invisible world of activity going on.
Welcome to the strange world of quantum mechanics. One theory is that this Casimir force could play a role in the ECAT. Imagine those tiny spaces between the nickel particles packed inside the tube. The Casimir force might be strong enough in those spaces to influence the behavior of electrons and protons, potentially even pushing them closer together.
So these invisible forces could be lending a helping hand to the reaction.
It's a possibility. Then we have the Aharonov-Bohm effect, which is even more bizarre. This effect essentially says that charged particles, like electrons, can be affected by electromagnetic fields even if they're not directly within those fields.
Now that sounds like something out of science fiction. How can something be influenced by something it's not even touching?
It seems counterintuitive, but it's a well-established quantum phenomenon. In the context of the ECAT, some theorists speculate that this effect might be involved in extracting energy from the vacuum itself.
So we're about tapping into the energy of empty space.
Right.
That's where my brain starts to melt a little.
It's definitely on the fringes of theoretical physics. But remember, we're trying to explore all the possibilities here. And then, of course, there's the concept of Bose-Einstein condensates.
Yes, Bose-Einstein condensates. I know it involves matter behaving strangely at extremely low temperatures.
Exactly. A Bose-Einstein condensate is a state of matter where atoms are cooled to near absolute zero, and they begin to act collectively like one giant atom.
So how does that tie into the ECAT? Rossi isn't cooling his nickel powder down to near absolute zero, is he?
No, not at all. But one theory suggests that the unusual energy production in the ECAT might involve the formation of a Bose-Einstein condensate not of atoms, but of quasi-particles called exciton polaritons.
Exciton polaritons. Okay, now you're really testing my science vocabulary.
Think of them as hybrid particles, part light, part matter. They form when you have a strong interaction between light and matter. And under very specific conditions, these exciton polaritons can form a Bose-Einstein condensate.
Okay, so maybe under the extreme conditions inside the ECAT, these exciton polaritons are forming a condensate and contributing to the energy production. It's still very theoretical, but at least it's a potential avenue for exploration.
Exactly. And that's just the tip of the iceberg. We have concepts like Zitterbewegung, which describes the rapid oscillation of elementary particles, and the electron energy distribution function, which plays a role in how electrons behave within a material. There are even more esoteric ideas like virtual particles, negative mass bosonic electrons, and exotic vacuum objects.
Wow, it's a whole universe of quantum weirdness. And somewhere in this sea of concepts, Rossi claims the ECAT finds its footing. But with so many theories floating around, is there even a consensus on how the ECAT is supposed to produce energy?
Unfortunately, no. There are many intriguing ideas, but none of them have been widely accepted or definitively proven. It seems like we're still in the very early stages of understanding this technology, if it is indeed a real technology.
It's fascinating, but also incredibly frustrating. It feels like we're trying to solve a puzzle with half the pieces missing.
That's a very apt analogy. And to make matters even more complicated, the experimental evidence surrounding the ECAT is also quite murky.
Okay, so we've explored the theory now. Let's dive into the experiments. What do we know about the tests that Rossi has conducted?
Rossi has conducted numerous experiments over the years, some private, some public, and some with independent observers. He claims to have achieved remarkable energy gains, producing far more heat output than the electrical energy input. He even says that the nickel transmutes into copper during the process, which would be a clear sign of nuclear reactions taking place.
Those are some bold claims. But independent verification is crucial in science. What do other researchers say about Rossi's results? Have they been able to replicate his findings?
That's where things get even more contentious. There have been very few independent replications of Rossi's experiments, and those that have been attempted have produced mixed results. Some researchers have reported seeing excess heat, while others have found nothing out of the ordinary.
So we have a mixed bag of evidence which only adds to the mystery and controversy surrounding the ECAT. It's like trying to grasp a shadow. The harder you try, the more it slips away.
That's a great way to put it. And to complicate matters further, there have been inconsistencies in the data that Rossi has released, as well as criticisms about his experimental methods and lack of transparency.
It sounds like we're dealing with a puzzle wrapped in an enigma.
Indeed. And this lack of clarity, coupled with Rossi's secrecy, has made it very difficult for the scientific community to take his claims at face value.
So where does all of this leave us? Is the ECAT a groundbreaking invention or an elaborate illusion? I'm guessing there's no easy answer.
You're absolutely right. After sifting through all of these sources, there's no definitive conclusion we can draw. The ECAT remains an enigma, a tantalizing possibility that has yet to be proven or disproven.
It sounds like we need more data, more rigorous experiments, and most importantly, more transparency from Rossi if we ever want to get to the bottom of this mystery.
I completely agree. But even with all the unknowns, there's another layer to this story that we need to explore: the potential implications of the ECAT if it were indeed to work as claimed.
Now that's a thought-provoking question. If Rossi's claims turned out to be true, what kind of impact could this technology have on the world?
The implications are vast, spanning across energy economics and even geopolitics. It's a topic that deserves its own deep dive, which is exactly what we'll be doing in the next part of our exploration.
This is where things get really interesting. Stay tuned as we unpack the potential consequences of the ECAT in Part 2 of our Teolumen Insights investigation.
Welcome back to Teolumen Insights. Before the break, we were talking about the ECAT and what it could mean for the world if it really works as claimed.
It's a big if, but it's exciting to think about. A world with cheap, abundant, clean energy?
It would be revolutionary. But as with any powerful technology, there are always two sides to the coin.
Yeah. What are some of the potential downsides? Where could things go wrong?
Well, for starters, think about the impact on existing industries. The fossil fuel industry, for example, would be completely disrupted.
Right. Oil companies, gas companies, all the infrastructure built around those energy sources.
Exactly. And it's not just the companies themselves. It's the jobs, the economies, the whole system built around fossil fuels.
That would be a massive shock to the global economy.
Absolutely.
Right.
And then there's the geopolitical implications.
Oh, yeah. I didn't even thought about that. The balance of power between nations could shift dramatically.
Right now, certain countries hold a lot of power because of their energy resources. That could all change.
It's like opening a Pandora's box. We might not be ready for the consequences, even if they're ultimately positive.
That's a good point. And even on a more practical level, there's the question of infrastructure.
What do you mean?
We've spent decades building our energy systems around fossil fuels and traditional nuclear power.
Power plants, pipelines, gas stations, the whole grid.
Exactly. The ECAT, if it works, would require a complete overhaul of all that.
Wow, that's a monumental task.
It is, and it raises a lot of economic and logistical questions.
Could we even adapt that quickly to such a radical change?
It's a valid concern, and then there's the question of regulation and control.
Yeah.
Who gets to decide how this technology is used?
Exactly. Who oversees production distribution? How do we prevent it from falling into the wrong hands?
There are so many potential pitfalls.
It's a reminder that technological advancements, no matter how promising, always come with a shadow side.
The ECAT wouldn't just solve problems, it would create new ones.
Precisely. It's not a simple equation of problem plus solution equals progress.
Okay, so let's bring it back down to earth for a moment. Have there been any attempts to commercialize the ECAT?
There have been a few notable ones, but none have really succeeded. Our sources mention a company called
Defcalion. What happened to them?
They were a Greek company that partnered with Rossi to develop and commercialize the ECAT.
So they really tried to turn this theoretical device into a real product. They did. They even conducted public demonstrations of their version of the ECAT, which they called the Hyperion.
Interesting. So what went wrong? Why aren't we all using Hyperions to power our homes right now?
Well, things took a dramatic turn. The partnership between Rossi and Defcalion fell apart.
What happened?
There were accusations of intellectual property theft, breaches of contract. It got messy.
Oh, wow. So much for a smooth journey to a clean energy future.
It's a familiar story, unfortunately. Big promises, high hopes, then a disappointing crash back down to reality.
A reminder that groundbreaking inventions are hard to bring to market.
They are. There are always complexities and hurdles.
So the ECAT journey is still very much in progress.
It is. But even though the ECAT itself remains a mystery, there are still valuable insights we can take away from all this.
Absolutely.
What?
What are some of the things we've learned?
Well, for one, it highlights the importance of critical thinking.
Right. We can't just accept claims at face value, especially when they sound too good to be true.
Exactly. We need to demand evidence, scrutinize the data, ask tough questions.
The scientific method is our best tool for separating fact from fiction.
Absolutely. And it also reminds us to consider the bigger picture.
What do you mean?
Technology doesn't exist in a vacuum. It's always intertwined with social, economic, political forces.
We need to think about the potential consequences of our inventions, both good and bad.
That's right. It's a call to be informed, engaged citizens, not just passive consumers of technology.
Okay, so let's talk about the skepticism surrounding the ECAT. What are some of the main arguments against Rossi's claims?
Well, the biggest one is the lack of independent verification.
Right, Rossi hasn't exactly been open to scrutiny from the scientific community.
He's been criticized for being too secretive, for not allowing his devices to be examined by independent experts.
And for conducting experiments that are hard to replicate or verify.
Exactly. It's the trust me approach, which doesn't hold much weight in science.
So until he's willing to be more transparent, the doubt will likely persist.
I think that's fair to say. But let's shift gears for a moment. I want to talk about some of the specifics of how the ECAT is supposed to work. You mentioned the nuclear active environment earlier.
Oh, right, the NAE.
Mhm.
It sounds so futuristic. What exactly is it?
Well, it's basically the environment inside the ECAT where those low-energy nuclear reactions are thought to occur. And one of our sources, a document from Teolumen, actually provides some interesting details about it.
Teolumen Insights. Let's hear it.
Okay, so according to this document, the NAE involves a nickel foam structure.
Nickel foam, what's that?
Imagine a microscopic sponge made entirely of nickel. They even give a specific measurement, 48 square meters per gram.
Wow, that's a lot of surface area packed into a tiny space.
It is. And that enormous surface area is thought to be crucial for creating the conditions necessary for those low-energy nuclear reactions to happen.
So it's not just about the ingredients, it's about creating the right environment for them to react.
Exactly. And remember how we talked about splitting hydrogen gas into individual atoms to get a higher concentration protons? Well, Teolumen's document suggests they have their own method for generating atomic hydrogen within the reactor.
So they were trying to optimize the process even further.
It seems that way. And then they talk about using magnetic fields to guide those atomic hydrogen atoms towards the NAE.
Magnetic fields,
Yeah.
like tiny tractor beams pulling those protons into place.
That's a great way to picture it. They even suggest that this whole process is multi-stage and depends on the specific geometry of the reactor.
So it's a carefully choreographed sequence of events.
It sounds incredibly complex. And there's even mention of restructuring the nickel lattice itself.
Restructure the lattice. That sounds like something out of a materials science lab.
I know, but think of it this way. The atoms in a solid are arranged in a specific pattern called a lattice. Teolumen claimed to have a technique for modifying the nickel lattice, making it less dense and supposedly more suitable for LENR reactions.
So they were manipulating the nickel at the atomic level.
Precisely. They even mentioned specific crystal structures. It gets very technical. But the point is, they were trying to optimize every aspect of the ECAT's design.
It shows just how much work went into this.
It does. And it also highlights how difficult it would be to replicate. Even if we knew the recipe, recreating those exact conditions would be incredibly challenging.
So the ECAT saga raises a big question. What if, despite all the skepticism, Rossi is right?
What then? It's a question with no easy answer, but it leads us to the most intriguing part of our deep dive, exploring the future that the ECAT might unlock.
A future filled with promise and peril. Let's venture into the realm of speculation and imagine what that world might look like in part 3 of our Teolumen Insights investigation. Welcome back to Teolumen Insights. We've been on quite a journey with this ECAT story, haven't we?
We have, from the science to the controversy to the potential implications. It's been a wild ride.
It really has. But now it's time for the grand finale, the moment of truth.
The what-if moment.
Exactly. What if Rossi is right? What if the ECAT actually works? What would that world look like?
Yeah. Well, it's a world that's both exciting and a little bit scary to imagine.
Yeah. How so?
On the one hand, we could be talking about a world transformed by clean, abundant, and incredibly cheap energy.
No more fossil fuels.
Yeah.
No more pollution. No more energy scarcity.
It sounds almost too good to be true.
But you said scary too. What's the downside?
Well, think about the disruption. Such a massive shift in energy production would upend entire industries.
The oil and gas industry would be devastated.
Not just them. Think about all the businesses that rely on fossil fuels, transportation, manufacturing, agriculture. The list goes on.
It would be a global economic earthquake.
And then there's the geopolitical impact.
Countries that currently hold power because of their energy resources would lose their advantage.
Exactly. The balance of power could shift dramatically.
It's like a domino effect. One change triggering a cascade of others.
And let's not forget the practical challenges of actually transitioning to an ECAT-based energy system.
Our current infrastructure is not designed for it.
We'd need to rethink everything. Power grids, transportation systems, even the way we design our homes and cities.
That's a massive undertaking.
It would require global cooperation and a willingness to embrace change on a scale we've never seen before.
So even if the ECAT works, it's not going to be a smooth ride.
It's going to be a bumpy road full of challenges and uncertainties.
But it's a road worth exploring.
It is. It forces us to confront some big questions about our relationship with energy, with technology, and with each other.
So what are the key takeaways from all of this? What have we learned from diving deep into the world of the ECAT?
I think the biggest takeaway is the importance of critical thinking.
We can't just blindly accept claims, especially when they seem too good to be true.
We need to question everything, demand evidence, look for independent verification.
The scientific method is our best defense against hype and misinformation.
It's also a reminder that technological innovation doesn't happen in a vacuum.
It's always part of a larger social, economic, and political context.
We need to be mindful of the potential consequences, both positive and negative.
It's not just about the science. It's about the human impact.
And most importantly, I think it reminds us that the pursuit of knowledge is an ongoing journey.
We may never have all the answers, but that shouldn't stop us from asking the questions.
The ECAT story, whether it ends in triumph or disappointment, has sparked a conversation about the future of energy.
And that conversation is one worth having.
It's a conversation that could lead us to a brighter, more sustainable future.
A future where humanity thrives, not just survives.
That's the ultimate goal, isn't it?
It is. And the ECAT story, for all its twists and turns, has brought us one step closer to that future.
It's shown us what's possible and what we need to be aware of as we continue to explore the frontiers of science and technology.
It's a reminder that the future is not something that happens to us, it's something we create.
And we create it through our choices, our actions, and our unwavering pursuit of knowledge.
So thank you for joining us on this incredible journey into the world of the ECAT.
We hope you've enjoyed it and that it sparked your own curiosity about the possibilities that lie ahead.
Keep asking questions, keep exploring, and keep believing in the power of human ingenuity to solve the challenges we face.
That's the spirit of Teolumen Insights.
This is Teolumen Insights signing off.